solve for the change in the absolute value of the change of the magnitude of the magnetic field with respect to time, this would be equal to the current times R over pi R squared. We can now solve 10 amps multiplied by the resistance that we calculated initially, 1.1 times 10 to the negative third ohms. And then this will be divided by pi times the radius of 0.05 meters quantity squared. And we find that the absolute value of the change in magnitude of the magnetic field with respect to time will be 1.4 teslas per second. This is our final answer. That is the end of the solution. Thank you for watching.
Welcome to Solver Phi.
100 seconds per day.
Okay, so assuming the switch is open,
R1 is
we have this following
7
setup here.
times 10 to the power 5
Now,
kilometers.
We're looking for the
and
EMF
R2
of
is
the
16
battery,
kilometers.
which we'll denote with
Then
the
we'll take a
epsilon there.
square. So that gives
And
us
so we're going to
finally
use
4.6
Kirchhoff's second law
times
for this. Now this is
10
his
to the
loop
power
rule.
3
And what this means is that when we
radians
draw a loop, any
per
loop in the
second.
circuit, the sum of all the differences in potential around that loop will be 0. So this this circuit contains two loops, one on the right-hand side and one on the left-hand side. So let's draw some loops with some directions on there. I'm drawing these in red.
Welcome to Spring LIB.
There we go. And
So
specifically,
here's a top
Kirchhoff's
view
law
of the
says that
setup.
around that
Here
loop,
we see that the bar is pivoted at this end, and the
around
bug
that loop,
sits here, and
the
this is the table.
difference in
So the
potential
bug
around the
jumps
loop
off
has to equal 0.
perpendicular to the pivot point. We say this is
Now,
the
change of
direction,
potentials include the
and there are
potential
a few
drops
notations
due to
that we
everything in
should
this circuit.
remember.
So this includes
Now
the
we're
battery
saying that
as
A
well as
is
all the resistors.
defined as
So let's specifically
bug,
talk about the right-hand
like
side loop.
A as defined
So
as the object bug,
the
and B for the bar.
battery here
So
is going to
MB
raise the
corresponds
potential,
to the mass
and then
of
it's
the
going to
bar.
drop across all the
Similarly, MA
resistors.
corresponds to the mass
So
of the bug.
the
And when the
signs on
bug
the resistors
jumps
are going to be
this way,
opposite that of the
then
battery, and that's
there
how
will
they're going to
be
equal
some
0.
angular
And we can actually
speed
write
or
that
angular
out
velocity on the opposite direction,
equation-wise.
and
so
we mark that as omega b.
Let's get a new
Now also we're
sheet up
given
here.
the length of the bar,
So,
which we call R here. So if
expanding
we
this out,
apply
we have
conservation of angular momentum
EMF
here, we see
minus
that before
the
collision, the angular
potential difference
momentum is 0 because the
across
system
the
was
20
at
ohm
rest.
resistor
But after the bug
minus
jumps, there will be
the
some non-zero angular
potential
momentum,
drop
and we can calculate that
across the 30
using
ohm
this
resistor
expression, where MA times VA
minus
is the linear angular
potential drop
linear
again
momentum, and we
across
multiply
the 50
that
ohm
by the
resistor.
radial vector. So that gives us the angular momentum. Since omega b is going in the opposite direction, so
Great.
we put a negative
So
sign
now,
after
basically,
that,
if
and
we can
then
find all these drops in potential, these three,
put the angular
we'll find
momentum
the
due to
EMF
the
of the battery.
pivot, or due to the bar, which
So
is
we're
IB
already
times
given
omega
this
b,
in the
where
problem,
IB is the moment of
the
inertia
change in potential
for
across the 50
the
ohm
bar.
resistor. That was 15
Now
volts, right?
we see
So
that
now
since
we
the
need to
bar is
find
pivoted at
the
one
change
end,
potential
so
across the
IB
30
will
ohm
be
resistor, and
1/3
we do that using
MBR
Ohm's
squared.
law.
So from
I'm not
here,
going to review Ohm's law because that was done in previous
we'll
chapters. But we can find the
equate these two
current in
things
this
before collision and after collision. And
in the
since
50 ohm
this
resistor
part is 0,
using
so
Ohm's law,
this
and that current is the
whole
same
thing should be equal
as
to
in the 30 ohm
L1,
resistor,
which is equal to
because
0.
these two are
So
in
from there,
series.
we get
And that
omega
current
b
is going to be
equals
0.3
to
amps, and you can get that just by dividing
3MA
15 by 50. So that's
VA
0.3
divided by MBR. So all we did
Excellent.
here is we substituted
Okay.
IB
We can also
by
use
this expression and then solve for omega
Ohm's
b.
law with this
And
current.
using the
This
given
current
values, we
3
were
amps
already given
in
MA,
this
MB,
30 ohm
R,
resistor
and
to find the voltage
VA.
drop across that 30 ohm
So using
resistor.
given values, we
Again,
see
I'm not going to
omega
get into
b
that
is
just because we already did that in previous
0.12
chapters. It's 9
radians
volts.
per second.
Great. So now we
So
see that if
to review,
we
omega b is the
add together this
angular
15 volt drop across
velocity
the 50
after
ohm
the bug
resistor
jumps
and the
from
9
the
volt
pivot,
drop
from
across the
the
30
bar.
ohm resistor, we're gonna get
In part B, we need to
24
find
volts
out
across
the
this half of
kinetic
the circuit.
energy
Now these two
of the
resistors are actually in
system.
parallel with this other 75 volt,
So
75 ohm resistor,
before
and that means
the
that the
bug
voltage
jumps,
drop across the
the
75
system was
ohm
at rest,
resistor
so the
is
initial
actually
kinetic energy
equal
was 0,
to the voltage drop
but the
across
final
the other two.
kinetic energy will be the kinetic
And that's
energy
actually
due
going to
to
become
the
really
bug
relevant for
jumping
us
off. So the
in a
velocity,
second.
the linear velocity
So
of the
let's
bug
just
is
rewrite what we've got here.
VA.
Let's say,
So half
okay,
mv squared is the
the
kinetic
EMF
energy of
is equal to
due to
then,
the
we're
bug
going to move all these voltages onto the other side and
jumps
make
at a
them
certain
positive.
velocity.
So this
Then we have
is
the rotational
the
kinetic
change in
energy.
voltage
This is because the bar starts rotating,
across
which
the
is
20 ohm
half of
resistor,
IB times omega b
and
squared.
then plus
And we already
that other
we have
24
already
volts
shown
that we
how
had.
to get IB and omega b. We already got omega b from
Remember,
the previous part.
the
So if we
24
put
volts is
all the
just the
numbers,
9
we
plus
see
the
that
60, or plus the 15.
the kinetic energy is 3.2 times 10 to
Great.
the power minus 4
So now
joules.
we have that. So now we just have to
And
find
in
this
part
voltage drop
C,
across the 20 ohm resistor. And we're going to do that again
the
with
source
Ohm's
of
law.
energy is basically when
So
the bug jumps,
delta V
it pushes the bar, and because
is equal
it pushes the
to
bar, there is some work done by the
IR.
bar, by the bug
Great.
on the system.
But we need to know the
And
current.
that
So let's go back
work
to our
done is
picture
being
here.
converted to the kinetic energy.
Yes, yes. And we have
We know
given
the current in the right half, and we know we
that the
can find the
heat
current in the left
passes
half.
from inner to
And then
outer
because of
sphere, that
Kirchhoff's
is
first
Q is
law,
equals to 100
because of
joule.
Kirchhoff's first law, those two
Now I am
currents are going to
considering a small
combine
strip
at this
at a
juncture, and
radius
they're
of
Welcome
both
to
going to
small
Spring
r.
pass through
LIB.
this 20 ohm
So
resistor.
area of this strip
We're told that an airplane
or
So
element is
has
given
we can
by
use
tip length of
that
Ohm's
is
law to find the
2.08
current through this
meters,
75 ohm
and it
resistor.
weighs 117 kilograms.
elemental ring
I'm not going to go
And
into
it
that,
is
applies
given
but
by
it is,
4
applies a
pi
torque
let's
of
see,
r
let me
square.
write this,
1,950 newton meters. The angle was
0.32 amps.
And thickness of this ring is
So the I
Now,
here
we're going to
is
assume that the
let
propeller is just
What about
a
in
bar
between
rotating
our
dr.
first
So
shell?
So rate
maximum
of
for
heat
that
flow
A
is
to
for
B.
1/12
this ring
Well,
is
remember
given by
that
squared.
and
in
that's
a conductor, the
just
total
dividing
electric field must
24
be
volts by
zero.
75
initial
ohms.
So there's no charge on the inside, nothing's induced.
that
So
is
anyway,
Q
we
is
can
equals
say,
to,
okay,
or I can say
this
Q is
0.32
equals
amps
to
B less than R less
minus
than
K
C.
going
We're
around
into
here.
4
supported
pi
region.
r square into
Our inner
And we have this
shell
by
0.3 amps
3r.
going around there.
has
Here the
They're going to
negative
combine
a
sign
here
total
to
indicates
charge
that
of
the
plus
temperature
0.62
2Q.
decreases
amps
And
with
so that
coming
is
increasing
our
down the 20
Q
radius.
enclosed
ohm
here.
resistor.
So Q enclosed
So
Now
they're going to
equals
integrate
combine
plus
on
2Q.
both sides.
So
So
that
this
means
will
that the
be
electric
dr.
field can be
First I
written
am
as a point
simplifying
charge
this. So
in
dr
terms of
upon r
the
square
maximum
equals to
or just this
minus
And
4
then
pi
we get some
writing
more
k
it
Ohm's
upon
law.
we
this
get
is Q
1
into
And
dt.
divided
we can
by
Now
4
again
integrate
pi
on
find
both
that
sides. So at
epsilon
radius
0
r1
current.
the temperature
times the
is
total
T1
charge
that
and at
inside,
radius
which is
r2 the
2Q,
temperature is
And that
T2.
divided
gives us
by
ultimately
R
we have
squared.
So
So the final speed is the square
0.62
root of 2
There we
times
go.
alpha
this
naught
will
times
comes
the
out
change in
minus
amps.
1 by r
The change in angle we're told is 5
r1
And
to
let's
r2
see
this
now.
is
C less
minus
than R
4
less
pi
than D,
k
so now we're
upon
in this
q
outer region,
and
okay?
this is
Finally,
T2
20
minus
ohms.
So
T1.
if we're in this
So
outer
after
region, I know that
0.9
electric
integration
field
we get the
must
value of
be
q that
equal to
is
0
4
And then we
pi
ask
here
how
in
k
much
this
work
region.
is done by the engine
Because
during
if we're
And
in
then
the
add on
T1
our
minus
in a
24
T2
volts
conductor,
to
the
the other
electric
side.
field,
this is
net electric
r1
field must be
minus
0.
r2
the torque
upon
Plus
times
2Q here.
angle of
So I need
rotation
minus
in a
2Q on
sorry
this
And the end
inner
of
this
this,
is
surface.
constant.
the EMF of our
But in
battery
general,
is
E
going to be
r1
still
r2
must be equal to
upon
0 there,
volts.
That's
because
simply
we are
just
inside of the
r2 minus
conductor.
r1.
And
1,000
Now
finally,
put
when
all
we
the
are
data in this
outside
equation. So this is
of this
100 is
system,
equals to 4 into
all we have
pi
to do is
into
take the
k.
total
This is
charge minus
50
4Q plus
minus
2Q is
10
minus 2Q. So Q enclosed
Okay.
is minus 2Q.
Now, part B.
And we get E equals
R1 is
Another
divided
example.
by
0.05 into this is 0.2
Could got
times
upon
simple,
-2Q
but it's actually a lot simpler
minus
problem.
over R.
Just have a
0.05.
25
From here we
volt
get
battery
the value of thermal conductivity K.
in a 50 ohm resistor.
So delta T equals
Alright.
the
After
change in
solving
go
we
ahead and
get
graph
K
this.
that is
divided by the angular
Since we
And
only
what do we
have
see?
one
3
loop,
watt per
0,
meter
so
degree
25
and
Celsius.
and the
Zero
So
given
here.
assumed to be
this is
constant.
the
This is
answer
Zero
of our
there.
50
and
ohms.
we wind up with 1.17
given
Between
question.
B
seconds.
and
So it
C,
took
Thank you.
1.17 seconds to go
we
through
see
5 revolutions.
Since we only have one
Two.
loop, let's just draw the loop.
Over
So now that we know
Welcome to
the
Solver
time
Fee.
Total
Welcome to
voltage
Solver
drop
Fee.
here we
across
have
all
the
these
work
things is
that
0.
and
was,
now
And that means that
we have to
this
remember
A
one
spherical
property.
ball
So
potential,
which is
even though
suspended
this
change
in
is
a
a
closed
quadratic
box
function,
and
has to be equal
you
to
can
this
get out
temperature
the
of this
graph.
spherical ball
That
is
means we
given
can
to us
just apply
and it
almost
is told that
And
it
see what
absorbs
happens.
any
We would
radiation
have
that
a
falls
negative
on it.
value
basically means
Now in
that
the
the
first part of
voltage
the
of the
question
outside
we
battery
have to find the amount
is
of
equal
radiation that
to
is falling on
So
this
that means
ball
that we
per
have
second of
instant
time.
current
So
or
first of all I am
expression
writing
that
the
you're
given
working with.
data for this
times the
question.
resistance.
So I'm graphing
We
it
have
now.
given the
I
surface
think
area
that
that is
all of you
20
should
semi
graph it as
square.
well.
So
Or I
basically,
can
this
say
tells us that
20 into 10 to the power
current
minus
500
To
and
see
4
what
meter
happens
square.
when you have a negative sign outside
Temperature
the
is given to us
expression.
that is
voltage
57 degrees
resistance comes
Celsius
out
or this is
2.5 amps.
330 Kelvin
In
and
fact, I
So
think it
time is
exactly
given to us
double.
that is 1
Because
second.
looks like
Now in the
we
first part of the
the
problem we
power
have to
starts
find
off as 0 because there's no
the
angular
radiation that
velocity, right?
falls
And then
on
it
it
ramps
that
up.
is
Welcome
given
to
by
Solver
And the angular
Fee.
E is
velocity
equals to
grows linearly.
A
So
into
the
sigma
average is
into
gonna be
For
T to the
part
power
A
4
of the problem,
and we
when
have
you graph
given
it,
the
there will
given
be
voltage
two
and
solutions.
constant that is
Average,
sigma
You
is equals
choose
to
the
At the
6
point
into
physical
10 to the
solution.
power minus 8
at the end.
watt
is
per
So
due
meter
to
in
the
this
square
wire
case,
is 10 to
alone
the
it
power
will be
4.
simply
Now
with the
put all the
magnitude
data in
of
this equation.
B
So
of
this is
C that is
20
equal
into
to
10 to the
naught
power
I
minus
of
4
wire
into 6 into 10
Alright.
to the power
divided
minus
There we
by
go.
8
2 pi
Okay,
times
so now we can look
AR.
at the
330
charges
to
that
the
This
are
gives
power
us
4.
mu naught
around
After
I
solving
of
this
this we
shell.
get
wire
this is
Okay.
divided by 6
1.422
Let's look at the
pi
so this
r.
is
intercepts
the
of our small.
amount
For
of
the wire,
radiation
we
Interceptors
have
of
that
our
is falling
small.
on this
B
Welcome to
sphere
Remember,
Spring
per
electric
LIB.
field
second of
must
wire
be
time.
0 because
greater
nothing
So
than
let's
is
see what's
B
given
inside
in
of
our
this guy.
problem.
Now
of
in
a
the
Whatever
second
wire.
that
part
is.
of the
So
So
Thus,
we are
for
given
this
the
guy must be
radius
BP
0.
r,
is
we have
equal to
given a
What about
temperature
on
BC,
the outer
2.5
surface?
which is equal to
that
Outer
is
surface
BC
minus
of a
2
wire,
must be the total
T1 is
charge on
given
the
to us
meter.
which is
I
2q.
of a
Then
200
wire
degrees
we can
Celsius
convert
must be
degree
into the
or I
to
can
loop.
say
radians.
473
Okay,
So we
Kelvin
can write
let's
the
and
look at
we
the
have to
formula.
We
find
have
the net
1000,
rate
so
of
we
For
have
inner
to or
surface,
from
we need to
ball
have
at
the
a
It almost seems
resistance
like
minus
number
into
so
degree.
it has to
minus
be
for most people
equal
it is that carbon dioxide
BP
and
is
temperature
also
T2 is
important
minus
initially
5 times 10 to the
as
that
it
is
minus
equal
relates
to
radians.
to
naught
climate
I of a
change because
Then
wire
carbon
we're
so
dioxide
given
is
the
the
flow
rate
rate
we're
exhausted.
can be
given
given by
And
W
that
at
term
minus
means something
Q
very
by
naught
2
I
specific.
is
of a
equals
So
to
wire.
we live on
2
Earth,
A
pi
into sigma
into
into
and
A
R.
we can
the outer
convert
1
that
to the power 4
Setting
we
minus
can
2 to
convert
the
that
power
BC
4.
radians
is
per
Now
equal to
put
second
all the
to
minus
data in this
around
radians
equation.
per
So this
BC
is
second,
20 into
B of
10
10
to
and
10
to
to
the
the power
light
I
minus
of a
4
1
into
wire
times 10 to the
6
power
into 10 to
radians
the
per
power minus
second
That's
8
too much
3
for
I
radians
of
per
a
and
second.
the
wire.
green
Now
area
the
resistivity
time
is
is
one
given
Which is
as
and here
so
this
the
is
5
it
hours,
sounds like
so
it
four
will come around
473
divide
to the
to a
power
little
4
bit
2
minus
minus
into
into
2
and
3
the
divided
into
by
light
10 to the
reaches
It
the
power
gives
power
us
4
1
3
point
times
We
10
wait
to the
for
power
after
time.
solving
6
this
minus
Since
2.
and
now
the green
For
area
part B of the
what this
problem,
does
the
is
direction is
it sounds like it will come around a little bit into and the light
some of that
reaches us
from
in that
here
atmosphere
to the
now
power
because this is
and the green area what this does and the way that it does that is it will come around a little bit into and help the light and reach that in that atmosphere and the green area what this does and the way that it does that is it will come around a little bit into and help the light some in that atmosphere relates to
Friction does what? Friction does what? Friction does what? Negative. Friction does what? Negative what? Done by the friction. Increasing velocity. Increasing data velocity, mp multiplication omega t. So it will be equal to 120 by 120 plus 2 multiplication 70 kg multiplication 3 radian per second. So you will get the value as 7. Sorry, it is equal to 1.3846 approx 1.385 radian per second. Now I will simplify part B of this problem. So in part B I will use the formula KET is equal to 1 by 2 IT omega t square equal to 1 by 2 is 1 by 2 m t multiplication r square multiplication omega t square which is equal to 1 by 2 m t r square multiplication omega t square which is equal to 1 by 4 multiplication 120 multiplication 2 square multiplication 3 square equal to 10802. Now I can write the value of kinetic energy Tp, kinetic energy Tp is equal to 1 by 2 ITP omega Tp square which is equal to 1 by 2 multiplication 1 by 2 mt multiplication r square plus mp multiplication r square omega Tp square. So this value will be equal to 1 by 2 r square multiplication 1 by 2 mt plus mp multiplication omega Tp square. So on solving it further it will be equal to, so this value will be equal to 1 by 2 multiplication 2 square multiplication 1 by 2 multiplication 120 plus 70 multiplication 18 by 30 whole square. So finally you will get the answer as 498.46. Now friction does work, friction does work, friction does work negative. So friction does work negative. Negative work is done by the friction, increasing parachute velocity, increasing velocity. So if he falls off the table, energy lost is gained. So I can write if he falls off the table, energy is lost. Energy is lost on his gain, to his gain. I hope you understand it. So this is the answer for this problem. Thank you for watching the video. Delta T upon delta T equals to minus 1 upon LIG.
Say that the resistance of R equals the resistance multiplied by the length over 1.69.
Now further we can
Negative and then multiplied by pi divided by the
now we have to integrate in both sides.
Quantity squared divided by at this point we will use that upon I will be equal to M1 plus M2 upon the absolute value divided by the resistance is equal to the absolute value of the change in flux with respect
from here we get the temperature
and then this would be essentially multiplied by 1 over R. And so this is going to be equal to I R squared over R multiplied by the absolute value of the change in the magnetic field with respect to the change in magnitude of the magnetic field with respect to time. And so this also with the absolute value of the change in magnitude of the magnetic field with respect to time.
Here we have to
R squared and solve
theta upon
multiplied by this is already calculated. 1.1 times with respect to time will be 1
we can simplify it further. If we assume the M1 S1 M2 S2 upon M1 S1 so we can say that the derivative is equal to T2 minus T1 e to the power minus delta T. That is our answer for this solution. Where we assume lambda is equal
Okay, so assuming the switch is open, we have this following scenario. Now,
in this question, we have to calculate the amount of energy radiated per second by the body.
And to bring you Copeland's second law,
this area of the body given to us is 1.6.
any moving surface,
Temperature of the body given to us
the sum of all the differences in potential
310
this
Kelvin.
contains, sorry, this
Given constant as the sigma is equal to 6 into 10 to the power minus 8
let's draw some loops,
watt per meter square.
some directions on them.
Now we know that energy radiated per second is given by
And specifically, Copeland's law says that around that
for black body emissivity is 1.
around that
Put all the potential
difference in potential
1.6 into
around that
6 into 10 to the power minus 8 310 to the power 4.
now
After
change
solving this,
potentials potential drops
energy radiated per second
since you use the battery as well as
This is the answer for this
so the battery is the potential and it's going to drop across so the sign of resistance will be opposite that.
in this question, we have to calculate the amount of energy radiated per second by a body, and for this we have data that is
so
surface area of the body is given to us A is
expanding this out
12 semi square
EMF
minus 10 to the power minus 4 meter square. We have given the temperature of the room that is welcome to Spring LIB 20 degrees Celsius and it is in thermal equilibrium with the room so body temperature is 20 degrees 293 Kelvin and we have given emissivity of the body that is 0.8 and given Boltzmann constant that is sigma is 6 into 10 to the power minus 8 watt per meter. So the heat radiated per second.
so we're already given this change by
E into sigma into T to the power 4. This is the amount of heat radiated per second. Now put all the data in this equation. So this is 12 into 10 to the power minus 4 0.8 6 into 10 to the power minus 8.